here's our sample. It's got a basic and acidic component to it, and Tina's going to weigh it. So she's zeroing the balance first, putting it on. She's going to get a mass of that. She's going to write that down in the lab book. You'll notice she's left the lid on, that's fine. But what's going to happen is after she's emptied what's in there, she's going to put the lid back on and weigh it again. Alright, so Tina is now going to empty the contents of the test tube. Now she's not too concerned about getting every last little bit out because we're going to re-weigh that test tube anyway, but she's going to get as much as she can. There we go. Alright, so put the lid back on please, and we'll re-weigh it. Alright, so Tina's got the empty test tube here and she's going to weigh it. And you'll notice she has left the lid on because that's what she did earlier. She weighed it with the lid, so she's weighing it empty with the lid. And now she's going to mark that down in her lab book. Alright, now that Tina's done weighing it, she's going to put it back where she found it. So this is a separatory funnel. I've put some water in it. It's got a stopper on top here, and you'll notice it's got a stopcock. Now the stopcock here is off. That means it's at 90 degrees, so what we're seeing here. And once it goes to being level with that, or being at the same angle, that means it's on and stuff will start running out. So make sure before you put stuff in it that it's off. Now what you're going to have in here is a mixture of probably dichloromethane and something aqueous. The dichloromethane will be on the bottom and the aqueous layer will be on top, and this will enable us to separate it. The purpose of what I'm going to show you here is how to shake a separatory funnel. Alright, so the stopper is on here. Make sure you've got your finger on the stopper here so that if pressure does build up, the stopper doesn't pop off. That's really important. When we shake a separatory funnel, we do so very gently. We go like this. Now I call this rocking the baby. Rock the baby. And occasionally we release the pressure like this. Now notice when I release the pressure, this is at an angle going upwards so that there's no liquid present in the neck of the flask, which would cause the liquid to pop out or be forced out with the pressure being released here. What might I call this? Right. Rock the baby, burp the baby. That's right. Rock the baby, burp the baby. Now burp the baby pretty soon after you start because pressure can build up fairly quickly at times. Now we rock the baby, we don't shake the baby. Now once, as a rule of thumb, I like to say that once you don't hear any more burping anymore or any more coming out, then you've pretty much done with this part, and then you can go on to the next part and do the separation. So this is a separatory funnel. It's got two different things in it. We've got an aqueous layer up the top. We've got dichloromethane on the bottom. And we have a ring here and a ring stand. This is the best way to hold one of these upwards. You can also use a clamp, and if you're going to use a clamp, clamp it around the neck, but I still recommend these rings here. If you've got a receiving vessel or something, put it down, don't leave it up way too high. Is that in the shot? A little bit, okay. I'm going to move that down a little bit. There we go. Alright. So your first thing is you want to separate out one of these layers, so you need to take out the bottom layer. So we've got a phase interface here, and you can see it's right about here. So what I'm going to do is I'm going to turn the stopcock on and we'll see what happens. So I do that, and you'll notice, well, it didn't do what I thought it would do. If you leave the stopper on, what can often happen is that nothing comes out. And the reason for that is it creates a vacuum up here. So before you release anything, you take the stopper off the top and then you release it down to where the phase layer is. When you're releasing the phase layer, what you want to do is, it depends on which layer you want. Now if you want the bottom layer, then you should leave a little bit of the bottom layer in here. If you're not that concerned about having some of the top layer in with the bottom layer because you're going to do something with the bottom layer later, that's absolutely fine. And you can take out a little bit of the top layer as well. So it all depends on what you're looking for. Alright, so here we've got the sample here. It's in the Erlenmeyer flask. And beside it we have 25 mils of methylene chloride. Go ahead and add that, Cassidy, please. Okay. So now we're just going to give it a bit of a swirl around. Now it doesn't have to completely dissolve. Now remember, this is a two-component mixture. There's an acidic portion and a neutral portion in here. And it may be that one might be more soluble or less soluble than the other. So the focus will be on simply getting the material into the separatory funnel. So go ahead and pour it in. You'll notice that we've put a funnel on top here of the separatory funnel. You'll also notice that the separatory funnel was in the off position, which is good, because otherwise stuff would have poured out through the bottom and it would have been quite a mess. Now we have another 5 ml sample of methylene chloride here as well that we're going to use to rinse it out. Now notice I wasn't that concerned about getting everything dissolved. So go ahead and pour it in. Now my logic with that is I'm thinking that once we add the second component, which is the sodium hydroxide, it will probably dissolve whatever happens to be in there. So where's the sodium hydroxide? Okay, let's go ahead and add the sodium hydroxide to the flask. Separatory funnel, I should say. Go ahead, sorry. So you'll notice that now there's two layers. You'll have a top layer, which is kind of skinnier, and a bottom layer, which looks bigger, but it only looks bigger because it's in the skinny part of the separatory funnel. So what's going to happen now is they're going to take that off, they're going to put the stopper back on the separatory funnel, and they're going to separate it. Alright, so who's going to rock the baby here? Alright, Jenny, only because she's the mother of 3, I guess, but... Alright, notice her technique here. Now, burp the baby. Okay, you'll notice you hear that little burp here. Alright, now she's got it up at an angle, so she's avoiding that. You'll also notice she's got put her finger over the stopper, which is really good because now that stops the stopper from coming out as well. And it sounds to me like there's not much burping left going on. Now you'll also notice that everything in the separatory funnel seems dissolved. Is that true? Yeah, that's great. Okay, so let's go ahead and we'll put that back in the ring. And again, she made sure that the stopper was off before putting it back down. That's really nice. All right, let's go ahead and remove the bottom layer.
Can we maybe bring it closer? Can we bring them over?
All right, yes, that's smart. Thank you. Okay, so let's go ahead and remove the bottom layer, Jenny. Oh, we're taking the top off. That's a great idea. That's wonderful. All right. Now, in this instance, we're quite interested in keeping the bottom layer. Well, we're going to do some stuff to the bottom layer eventually anyway, I think. But she's going to go ahead and remove the bottom layer. We're going to leave a little bit of the bottom layer in the separatory funnel. So she's being careful here about how much she's releasing. Just stop for a second there, please, Jenny. And let's go ahead and just zoom in. You can see how much she's got left there. And you can see there's not very much left in there. All right, so we'll stop it there for a second. Now the intent of this is that we're supposed to take as much of that bottom layer out as we possibly can. So now what we're going to do is we're going to remove the top layer and put it into a separate flask. Go ahead. Now what we're trying to do here is extract as much of the acidic portion as we can out of the bottom layer. Because at the beginning, that's where everything was. It was in the bottom layer. The top layer is basic. It's the sodium hydroxide. Okay, so go ahead and put that off to the side, please, Jenny. And go ahead and put that back in. No, back. It goes back in into the funnel. There we go. All right. Now we're going to add sodium hydroxide to that again. Alright, it's good. And we're going to do the separation phase again. You'll notice that most of the separation goes on in the first step. So you don't get very much of the action going on in the second. Right, so what Jenny's going to do now, she's going to release that bottom layer again. And she'll probably just leave a very small portion of the bottom layer in with the top layer. Okay, that's good. Alright, so now you're going to take the top layer and add it to the other portion of top layer that you've already got there. So we're putting the second part of that sodium hydroxide layer into that container there. Just the whole thing. I'm actually going to add a little bit of a step in here as well, because we still have a little bit of methylene chloride on top of that. So why don't we go ahead and pour that layer, pour both of those things, or just this sodium hydroxide layer back into the separatory funnel, and we'll separate off any of the methylene chloride that happens to be in there with it. Of course, that'll be on the bottom, the methylene chloride. So put that into another, let's put it into another flask here. It's going to be a waste beaker in the end.
You're using a flask? Or you want just a small one?
That's fine. No, you're good. That's all right. Alright, so go ahead, and this time you don't want to leave any methylene chloride in there, so you might take off a little bit of the top layer as well, because that'll help purify it. Okay. Go ahead.
Should I?
Yeah.
Because there's some on top.
That's all right. Okay, that's fine. No, you're good. All right. So take that away and now put it back into the sodium hydroxide flask. Alright, so now we have a fairly pure sodium hydroxide layer to work with. Now what we've succeeded in doing here is getting all of the acidic portion pretty much into the top layer, which was the sodium hydroxide layer. That was the top layer. The bottom layer now should just be mostly the neutral fraction, or the neutral component.
Okay.
Yep. So go ahead and let's add the methylene chloride back in. I'm glad you turned the stopper off. That was good. So now we're washing the methylene chloride with water. So go ahead and pour it in. We're also going to do the extraction kind of thing again. So we'll take that off and we'll do the. No. You're going to shake it. Yeah.
Rocket first.
Yes, rocket first. That's right. Yeah, you'll notice there's not too much air coming out of there, so you can probably just go ahead and do the separation here.
No, it's is to put that into a 125 Erlenmeyer flask.
Okay, so go ahead and get a clean 125 Erlenmeyer flask to put that in.
Is that what you have there? Yeah.
Okay.
Well, maybe because it drops off the side.
Yeah, let's make sure that it doesn't come out. There we go, that's better. I like that. Now Jenny's going to leave a little bit of the methylene chloride layer in the top because we don't want it too wet. Now in this layer that Jenny's taking out now, this is the bottom layer, that's where you're going to find the neutral component. The acidic component is in the top layer because it reacted with the base. She's leaving just a tad little bit of methylene chloride, not too much though, in that separatory funnel. There we go. The rest of that can be discarded. We're not interested in what's in the funnel now. That was just a wash solution.
So that I'll label the flask.
Okay, so you can put that in the waste container. There we go. That's good. All right. So in this Erlenmeyer flask we have the methylene chloride layer, and we're going to dry it with some magnesium sulfate. So the question of course is, how much magnesium sulfate do we add? So Jenny, go ahead and just grab a little bit on the end of a spatula. Let's say, let's see. That's a good amount. Yeah, that's good. Just go ahead and stick it in. Now what we do is we swirl it. Go ahead and swirl it, please. Alright, let's bring that closer to the camera, please, and stop swirling it for a second. Now what you'll notice is that some of it will stick to the bottom and some of it may not stick to the bottom. Is it all sticking to the bottom, Jenny? Do you see that, or is it, what's it doing here?
It looks mostly at the bottom. Yeah.
Okay, so it looks like it's all stuck to the bottom. So what that tells me is we probably need to add a bit more magnesium sulfate. There needs to be enough magnesium sulfate added so that it dries the solution, which means that when it hits the water, it forms this gel which sticks to the bottom. So Jenny's going to add a bit more, probably about double what you added previously. There we go, that's a good amount. And now she's going to swirl again. And what she's noticing here, bring it close to the camera please, and stop swirling for a second. You'll notice that there is a fair amount that's kind of floating around that's not stuck to the bottom. So as long as you've got stuff that's not stuck to the bottom, then you've added enough. If it all sticks to the bottom, it means you need to add more. How much do you add? Put some on the end of a spatula and just chuck it in. That's usually enough. Right, in this next step, we're going to decant this, and decant means we don't swirl it, Tina. we let it settle so that the solid stays on the bottom, and then we can slowly pour it into the flask by leaving the solid on the bottom. We do not want that solid in that round bottom flask. That's very good. Alright, so she's just decanting, leaving the solid in the flask. Now she's going to have to stop at some point, otherwise she'll be in danger of getting some of that solid into the flask. Now if you're having trouble with the solid, then what you can do is you can filter it. You can put a piece of filter paper in there and filter out the solid instead. Okay, that's good. And don't we need to add a little bit of methylene chloride to that to rinse it out as well? Yep, that's right. Yeah, so I've got a little bit of methylene chloride here. We're going to rinse off that solid that's in there a little bit. Again, we don't want to get that solid into the flask. So Tina's just doing a little bit of a rinse here. That's good. And now she's going to pour that in. But again, she knows that she's not going to get every last little bit of that in there. But it's enough to kind of rinse it off and get as much of that material in there as we can. That's good. So we've got a rotary evaporator here. The purpose of this is to take a liquid out of a flask and evaporate it, leaving the solid in the flask. And in this instance we have a condenser. Could you please point at the condenser? Jenny, up the top. That's him. That's the condenser, right? And now she's going to go ahead and put the flask on the rotary evaporator. And you'll notice she's using a Keck clip, and in a Keck clip you can see that the big part goes around the big part and the little part goes around the little part. I'm going to go ahead and zoom in on the joint there, and you can see that she's holding on to it until the vacuum takes, because the vacuum's not on yet. Okay, Jenny, go ahead and turn on the vacuum, please. That's that green switch down there. She's done that. Now she's going to turn, there's a knob up the top of the condenser. She's going to turn 90 degrees towards her. I'm going to go ahead and zoom in on that knob. Make sure that you all can see what I'm talking about here. Okay, remove your hand, please. There we go. So that's 90 degrees towards us. Alright, now she can remove her hand from the flask. And now she's going to turn on the spinner. There's the switch there, that's good. And now she's going to turn on the spinner. Alright, so she's turning it back to 0, and now she's going to turn it all the way up. You'll notice it's spinning. And now she's going to lower it using that into the water. Alright, so we'll know it's done once that solid appears in the flask, and then we'll probably wait another minute after the solid appears to wait for it to wait for the solid to completely dry there. Now the water in there is warm, and that's going to help with the evaporation here. And what we should see here, let's make sure that water's on. I'll turn this water on over here. And we do have water running through that condenser as well. And the idea here is that we're going to end up having the vapor come up from the flask and condense on the condenser and run into that flask. Now sometimes with very low boiling things like dichloromethane, what happens is that it never actually even condenses. It just goes straight through and out through the vacuum assemblage, so we don't even see it. But I do think there is a little bit of liquid coming over. Do you see any liquid coming over there, Jenny, or is it just my imagination?
I think it's just starting to condense.
Okay, there's a little bit of condensation occurring there, but not a whole lot. But that doesn't really matter. Now let's take a look at this flask here. I'm going to zoom in on it. And you'll notice the presence of a white solid there. So that's our signal that things are almost done here. There should be no liquid left in the flask, and you'll see that it should be pretty much complete with white solid there. We're going to leave it go for about another, say, 30 seconds, just to make sure we get pretty much all of that liquid out of the flask. And then we're going to reverse the process to remove it. Go ahead and remove it, please, Jenny. So she's lifting it. And now she's turning off the spinner. Now hold on to the flask, please, for this step. There we go. Now she's turning the vacuum off, which means that she's turning it down 90 degrees and then turning off the vacuum. Okay, remove the Keck clip, please. And then gently remove the flask from the end. It should come off fairly easily. If you have to, you can always hold on to the other part of it and then rip it off. So that's good. That's good. Alright, so what Matt's going to do is he's going to bend the top part of this spatula here, just to make it a little bit easier to scrape out the solid. And so if it's not bent, yeah, that's a little bit more. Bend just a little bit more. Okay. Alright. Okay, a little bit more. Can you bend it, the top part just a little bit more? Okay. That's great. Alright, that's good. Now he's going to stick it in there, and he's going to scratch around and just try and get as much of the solid down into the bottom of that flask as he can. Just some vigorous scratching there, please. There we go. So you notice he's just going around the flask here. He's going to scratch out as much as he can. And then that solid is going to be poured out onto this weighed watch glass that he has in front of him here. So you can't get every last bit of solid out of there, but you try and get as much as you possibly can. It's kind of why we bent the spatula, is so we can reach up onto the top parts of that flask, so we can get out as much as we possibly can and have as much to report in our yield as we could.
Whoa, whoa, whoa.
Alright, so Matt's probably got about as much as he can out of there for now, so go ahead, Matt, and pour it out onto the watch glass. And that's pretty much how we get it out. Now he's going to go weigh that. As we said earlier, that watch glass was weighed, so now they can figure out what mass they have. And remember, this is the neutral component, the one that came from the methylene chloride. So what we've got here is the sodium hydroxide solution, which contains the acidic component, but it's presently in the form of its anion, A-. So what we're going to do is we're going to add concentrated hydrochloric acid to this to bring it back out of solution, and then what we're going to do is filter it. It's going to be filtered using a Buchner funnel. Alright, so here's how we would do that. Now over here we've got a watch glass, stirring rod, and some litmus paper, which we're going to have here as well. We're going to use this to test for litmus. Now the way to test for litmus is to stick the stirring rod into the solution and then put a drop onto the litmus paper. What we don't do is dip the litmus paper directly into the solution. What that will tend to do is dye the solution, because stuff from the litmus paper will go into the solution. So we don't want that. Now we're going to add concentrated hydrochloric acid to this. You'll notice that it's in ice. The reason for that is because this is a very exothermic process. When you add concentrated hydrochloric acid to sodium hydroxide, it tends to heat up. So we want to make sure we do this in the fume hood, and we do it while this is in the ice here. So I'm going to go ahead, I'm actually going to take it out of the ice, and I'm going to show you how to use a dropping bottle. Now this is called a dropping bottle, and we do not need to remove the lid to get the hydrochloric acid out of here. What you'll notice is these two little nubs on the side. What you want to do is turn the top of this so that it's in line with one of the nubs. Now it's ready to work. To use this, what I will do, so I'll take this out of here. Generally you would keep this in the ice, but I need to show you this. So you just pour this like this, and you'll notice that drops will appear at the end. And then you just add those, and you're going to add enough of this so that it ends up forming this white solid in the solution. Now occasionally, you'll give this a stir, and what might happen is that white solid, just like you saw there, will end up disappearing. Now I'm not going to test this for litmus yet. Why? Because I haven't got all the solid coming out yet. There's no point. I know that if I test this for litmus now, it's going to end up being blue, and that's going to be pointless. So I'm just going to go ahead and add more hydrochloric acid. I'm going to keep on adding it until I get solid, and then when I stir it, that solid won't dissolve, or it won't go back into solution. Now keep in mind, I will do this, I should be doing this in the fume hood, but I need to be able to show this on camera, which is why I haven't been doing that. This hydrochloric acid is somewhat noxious. You can probably even see the steam and smoke coming off it. It's not very pleasant to work with. This is why I do it in the fume hood. It's becoming a bit worse now, so alright. So I'm going to give this a bit of a stir. Now look at this. Now I'm beginning to get a lot more solid in there. Now I'm still not getting a whole lot. Looks like a lot of it's going back into solution. So I'm going to add a bit more of this. You really can't add too much hydrochloric acid, not really. But you want to add enough so that you're getting this nice precipitate that's not going to go back in solution. Alright, just a little bit more for luck here. Make sure I get all of it out of solution here. There we go. So you see a very nice portion of white solid there. I'm going to try a little bit here with litmus now. Make sure that it has indeed enough acid has been added. You can see the blue one there, that was the initial one that I did. And here is the one I've just done now. You can see it's red on the bottom. That means it's acidic, which means we've added enough of the hydrochloric acid here. And now what you would do is you would leave this in the ice for a bit to cool before you filter it, to make sure that you got a decent yield of your nice crystals. How you're going to filter this? You're going to use a Buchner funnel. I'll show you that in a second. Alright, what we have here is the Buchner funnel setup. So what you've got is the Buchner funnel itself. You'll notice that it's clamped. That's very important. These things are top heavy. They fall over all the time. Cassidy, would you please get the filter paper? Would you show that to the camera there? So that's the filter paper that fits in there. It fits into the bottom part. Let's go ahead and show that. There we are. Alright, this one's already wet. Usually it's good to wet this down once you put it in. We've got also a seal here. That's important. If we don't have a seal, it won't form a vacuum. You'll notice that we have the vacuum tube here that's connected to a trap, and that trap is then connected to the vacuum pump down here. And it's important to have the trap there, because what happens is sometimes people will have this, fill this up too much, and then it will go through into the trap. I don't want that to happen. Be careful, be mindful, look at it, make sure that the level of the liquid doesn't go above about here, and if it does, go ahead and put that into the waste container. Again, make sure you clamp this, it's very important. Alright, so we've got our stuff here, it's ready to roll, so Cassie's going to go ahead and filter it. Tina, would you mind turning that on, please? Right, so she's turned on the funnel, and Cassidy is swirling. She's swirling it very vigorously, and then she's going to dump it into the Buchner flask, and she's going to do so quickly enough that it doesn't leave any crystals in there. Let's have a look at the crystals there. Right, so you see there's some crystals left in here, but she did a pretty good job. The faster you dump it, the better. And now she's got, go ahead and she's got some ice cold water here, but if you don't have any ice cold water, you can always make some by putting some water and ice together and just taking the water after you've done that. Now she's swirling it with that solution there, and she's going to go ahead and dump that too. Anything left, we're just going to leave it be. Go ahead and stick it in the camera here. Yeah, see there's nothing left here, just a little bit, but it's not worth getting all that out. We're just going to go ahead and leave it in there. So just showing you what it looks like inside here. So you can see there's the acidic component, all filtered, and it'll probably need a little bit to dry, maybe about 10 minutes because it was in water. So 10 to 20 minutes for water, probably less for other solids other than water. Alright Cassidy, go ahead and take off your acid portion here. And you can see what she's doing is just using a spatula here to remove the solid portion. It should look fairly dry. If it looks really wet and pasty, it probably needs a bit more time. And it's probably the result of not having a good enough seal on the vacuum to begin with. But that looks really nice and dry. So she's just going to empty all of that out onto a watch glass. Then she's going to weigh it, and then she's going to use some of that for her melting point. First thing we do is we turn the power on. That's always smart. Now we've got here the two capillaries, and one of these is actually marked as red. That's the acidic portion, and this is the neutral one that's in here. It's not marked. Now what you'll notice is on the side of this melting point apparatus, there's a little bit of a hole down here, and that's where you stick your capillaries, right in here. So when you put that in, you look through the magnifying glass on top until you see the ends of your capillaries down at the bottom, so that you can observe the melting. Now if you look at the melting points that we could possibly have for the unknown compounds, remember I've got 2 acidic portions, 2 neutral portions there. It turns out that the lowest one melts about 110, 113 or something, and the other one melts about 133. So what I'm going to do is I'm going to first of all set the plateau, and what I do there is I do plateau, set, and then I hit this up button here. Now I'm going to do this to about, say, 105, right? That's below the melting point of what we expect the lowest one to be. There we go, 105 to do that. Now, so the plateau is set. Now I hit start. Now what's going to happen is that this number here, can you see that in the thing? Alright. So that's going to go up fairly quickly. It's going to go up fairly quickly to 105. Once it hits 105, what's going to happen is you'll hit start, and then it will go up fairly slowly. And then you'll be able to observe both of them melting while looking through the top of the magnifying glass here. So here's the shot through the magnifying glass. It's pretty hard to see, but you can see the ends there of the capillaries. And we'll be looking through that, waiting for that to melt. Presently though, the plateau is going up, and we're waiting for it to hit 105. Okay, so now the 105 has been reached at the plateau, so now we're just going to hit start and we're going to watch it go up. Now of course Tina's going to be looking through that and making sure that it hasn't melted yet.